35% of the fabrication tools running inside China's semiconductor fabs are now sourced from Chinese suppliers, a reading that arrived ahead of the schedule its own planners had set. The restriction that was supposed to hold that number near zero was ASML's export block, compounded by the Foreign Direct Product Rule applied to toolmakers across Japan, the Netherlands, and the United States. Two dated readings of that domestic adoption gauge, the gap between them, and the mechanism that moved the needle. That is what this measures. The number to watch after this is 70% by 2027. Start with the then reading, somewhere in the 2019 to 2020 window, before the full extension of export controls to semiconductor equipment, the domestic tool adoption gauge inside Chinese fabs read roughly 10 to 15%. That fraction was not evenly distributed. It was concentrated at the back end of the fabrication process in packaging, wet cleaning, and thermal processing, the steps that sit downstream of the patterning work and are less demanding in their precision requirements. At the front end, where lithography exposes circuit patterns on silicon and etch chambers, carve those patterns into the material, domestic tools were effectively absent. The immersion lithography category, the one that determines what node a fab can reach, reads 0% domestic. ASML and Nikon held the entire installed base. Applied Materials, Lam Research, and their peers held the etch, deposition, and metrology categories that surround lithography. A Chinese fab in 2019 was, at its most sensitive steps, running almost entirely on imported machines, 10 to 15%, back-end weighted, front-end foreign. That baseline matters because it sets the scale of what the now reading represents. By 2024 into early 2025, the same gauge reads approximately 35%, and it now includes categories that were not domestic at all 5 years earlier. Naura's process tools for the 28 nanometer node are in mass production, meaning they have cleared yield validation, customer acceptance testing, and process integration inside operating fabs. That is not a prototype milestone. Mass production means the tool has been qualified against a process specification by a paying customer, installed in a production line, and is running wafers. The transition from qualification to mass production for Naura's 28 nanometer tools took roughly 2 to 3 years from approximately 2021 or 2022 to 2024, a compression of the reliability proof timeline that Western incumbents typically measure in half-decades. Alongside that, SMEE's 28 nanometer ARF immersion scanner is in customer verification. Verification means the tool is inside a fab, printing production representative wafers, and its overlay accuracy and throughput numbers are being evaluated against process specifications. Verification is not production. The gap between those two states is where immersion lithography tools have historically spent years before achieving the uptime, overlay consistency, and sustained throughput that production volume requires. But verification at 28 nanometers means SMEE has crossed the prototype boundary. The tool exists, it is printing, and a customer is measuring whether its performance meets the bar. That is a different category from a scanner demonstrated in a laboratory. 35%, now including 28 nanometer etch, deposition, and metrology. One immersion scanner and verification. The gap between the 10 to 15% then reading and the 35% now reading is roughly 20 to 25 percentage points over 4 to 5 years, and it arrived ahead of the intermediate plan target. That delta does not emerge from a single cause. 3 mechanisms are running simultaneously, and they reinforce each other in a way that a single policy lever would not have generated on its own. The first mechanism is capex reallocation. Before 2022, the dominant share of Chinese fab tool spending flowed outward to ASML, Applied Materials, Lam Research, KLA, and Tokyo Electron. The export control extensions that took effect from 2022 onward eliminated the option of buying Western tools for restricted applications. Applied Materials, Lam Research, and KLA have each reported material declines in their China revenue during 2023 and 2024. That revenue did not evaporate, it redirected. Fabs that had previously treated domestic tools as backup options or as a policy compliance gesture were compelled to treat them as primary suppliers. The financial flow that had been leaving China to buy ASML scanners and Applied Materials etch chambers stayed inside China and funded Naura's production ramp and SMEE's verification program. The wall did not hold the gauge at zero, it turned the gauge into a procurement mandate. The second mechanism is co-development under constraint. A supplier that knows you have no alternative sharpens its tools differently than one competing for a discretionary contract. Before the export wall, Chinese fabs sent field engineering problems to Western vendor hotlines because they could. After the wall, those problems went to Naura and SMEE engineers embedded in the same facilities. The iteration cycle that used to cross an ocean and a license agreement now crossed a building. Physical proximity under constraint is a different kind of pressure than market competition under choice. SMIC and Hua Hong provided process data and test wafers. Naura iterated hardware and software. The absence of a Western incumbent to default to kept both sides invested in making the domestic tool work, rather than issuing a support ticket to a foreign vendor. The 35% reading is partly the gauge on that iteration loop closing. The third mechanism is the feedback loop between headcount and hardware maturity. Government subsidy flowing into toolmaker research and development-funded engineering headcount at Naura, SMEE, AMEC, and their peers. That headcount, working directly on process problems from operating fabs, generated the iteration speed that compressed Naura's qualification timeline. The velocity of the delta, from roughly zero domestic 28 nanometer process tooling to mass production ready inside roughly 4 years, is the reading the percentage alone understates. The headline number reports where the gauge sits. The timeline reports how fast it got there. The 35% figure is real, but the instrument names its own uncertainties before proceeding. 3 of them carry weight. The first is the difference between claim and independent proof. The 35% figure derives from a combination of company disclosures, state planning reports, and analyst estimates from groups including CSIS and Rhodium Group, not from a single audited source with a standardized methodology. Tool adoption can be measured by unit count, by tool value, or by the fraction of process steps covered, and each method yields a different number. A gauge reading of 35% by unit count in back-end tooling looks very different from 35% by value across all front-end critical steps. Until independent process audits are possible inside Chinese fabs, which they are not at present, the headline figure carries a wide confidence interval. The direction of the movement is confirmed, the precision of the number is not. The second uncertainty is that verification is not production. SMEE's 28 nanometer ARF immersion scanner is in verification, not in mass production. Verification can fail. The tool could clear optical performance benchmarks and then struggle with overlay consistency across a full production run or with uptime under continuous fab conditions. The history of lithography tool development is full of scanners that passed initial verification and then required years of further engineering before reaching production yield. The gauge will not move to 70% on the strength of a scanner and verification. It moves when that scanner is running reliably in volume, at the throughput numbers a fab's economics require. The third uncertainty is the asymmetry of the remaining gap. The first 35 percentage points came disproportionately from tool categories where the precision requirements, while demanding, were within reach of domestic engineering within a few years. Packaging, thermal processing, certain etch and deposition steps, and back-end metrology are not easy, but they are not immersion lithography. The next 35 percentage points require domestic wins in overlay accuracy at the sub-nanometer scale, in high aspect ratio etch uniformity, and in electron beam metrology at resolutions that push against the physical limits of the measurement itself. These are not categories where procurement mandates and fab co-development cycles reliably compress decades of incumbent process knowledge into 3 years. Heat management in high-power etch chambers, mechanical vibration isolation in immersion scanners, and source lifetime in deep ultraviolet optics are engineering problems that do not yield to capital alone. The curve does not simply extrapolate, it steepens at the hard end. The instrument names its own uncertainty. 35% is real, the direction is real, and the mechanism is real, but the second half of the climb to 70% is structurally harder than the first half. And one scanner and verification is not a production-qualified installed base, the delta is confirmed. The trajectory is plausible but not guaranteed. The 35% figure also misleads if read as a uniform spread across the fab. It is not. The headline adoption rate is heavily weighted toward back-end and non-critical front-end steps, which means it flatters the depth of self-sufficiency at the nodes that matter most. A modern leading-edge fab runs several hundred distinct tool types. 35% domestic is not a rounding error. In rough terms, it represents more than 100 categories where a Chinese vendor has cleared a customer's process qualification. But if the majority of those categories are downstream of the patterning step, the choke point remains where it was. The lithography gap at leading edge is still the single largest drag on the gauge. Progress towards 70% by 2027 requires the gauge to close at the hardest end of the spectrum, not just accumulate more wins in segments already above 50% domestic. Follow one category through the chain to see what the delta looks like in concrete terms. In 2020, the Immersion lithography category inside Chinese fabs read 0% domestic. ASML held the production qualified installed base. Nikon held the remainder. A Chinese fab that needed an immersion scanner placed an order with one of those two suppliers, waited for an export license, and received a tool with field engineers from the vendor company who owned the process knowledge. By early 2025, SMEE has a 28 nanometer ARF immersion scanner inside a customer fab printing wafers under process evaluation. The category has moved from 0 to 1 tool in verification. That is a small absolute number against an installed base of hundreds of scanners. It is also a categorical shift, from a line item that read 0 to a line item that reads non-zero and is under active evaluation. If that scanner clears verification and enters commercial volume production, it becomes the first domestically produced immersion lithography tool in Chinese fab history to do so. And the gauge moves in the category that has been holding the headline number back most. The 2027 target of 70% was set when the domestic gauge read well below 35%. Beating the intermediate milestone means one of two things. Either the target was set conservatively to allow for slippage, or the acceleration of domestic procurement driven by SMIC Hua Hong and their peers explicitly redirecting capital toward Chinese tool vendors has run faster than planners projected. Both are probably true in different proportions. What the early arrival of 35% does not mean is that the remaining gap is equally reachable. The first half of a climb under constraint often moves faster than planners expect because the easy categories yield quickly once procurement mandates and co-development cycles are in place. The second half moves slower because it requires winning in categories where the incumbent's advantage is measured in decades of process refinement, not just in export license availability. The remaining 35 percentage points to 70% are not symmetric with the first 35. Fabrication tools are the deepest choke point in the semiconductor supply chain, sitting below chip design, below fab process, below packaging. A chip can be designed with domestic design software and fabbed on domestic silicon, but if the machine that etches the pattern came from Lam Research on an export license, the supply chain has a foreign joint at its most load-bearing point. The 35% reading is the gauge on that joint. It is moving. The capex that used to flow to ASML and Applied Materials now flows to Naura and SMEE. The process problems that used to go to Western vendor field engineers now go to domestic engineers in the same building. The tool qualification cycles that used to measure in half decades are now measuring in 2 to 3 years. The wall did not hold the number at 0, it turned the number into a domestic procurement mandate, and the mandate is running. 35% arrived ahead of schedule. 70% is 3 years out. The instrument is still running. The next reading to watch is whether SMEE's 28 nanometer ARF immersion scanner clears verification and enters commercial volume production before the end of 2025. If it does, how many percentage points does a domestically produced immersion lithography tool cleared for production add to the gauge on its own? That single data point may be the most load-bearing number between 35 and 70. It is also the number that will tell whether the second half of the climb is running at the same velocity as the first, or whether the steepening curve the physical limits predict is already visible in the data. If you want the next dated reading when it lands, subscribe. This channel reports the delta, not the announcement.